Okay, you're welcome again to Igcse 058023. Right, so in this one we're trying to look at paper 2 extended. Question number 1 says write the number 2,002,002 in figure. So we should write 2,002,002 in figure. So the easiest way to achieve this thing is to write them separately. Then you can now sum them together. So we have 2 million. Of course, million is 60. Then we have 2,000. Where does 2,000 start from? So we have 2,000. So we have 2,000, then and 2. So when you bring them together, you have 2,002, 0,002. So this is the answer. 2,002, 0,002. Okay, question number 2. So put one pair of bracket into this calculation to make it correct. So put one pair of bracket into this calculation to make it correct. So here it means, well, where are we going to put brackets such that when we subtract 5 minus 4 times 3 minus 9 minus 2, we'll end up getting 0 at the end of the day. So first of all, what you will do is obey board mass first. So let's try to obey board mass here. If I have 4 times 3, board mass, we have to multiply before we can subtract 1. So in this one, we have multiplication here, multiply 4. So here we have 4 times 3. 4 times 3 will give us 12, then minus 5, then minus 9, minus 2. So I just try to bring down everything down. So 5 minus 12 will give me minus 7. So minus 7 minus 9 minus 2 will not give me anything. But if I remove minus here, I'll say 4 minus 2. 4 minus 9 will give me minus 2. So minus 2 minus 2 will still not give me the answer. So the solution to this is that if I put plus here, for example, and I remove this minus here, if I didn't consider this minus here, I put plus here, for example, I'm not having, okay, let's say the minus is still there, sorry. So if I put plus there, I'll have minus 7 plus 9 give me 2. 2 minus 2 is 0. So it means the thing falls here. So it falls here. So for me to get something, it falls between this range. So what I will do here is to obey that rule. Let's say I have bracket here, for example. So after multiplying 12, I'll have it like this. So when minus is now used to open the bracket, I'll end up having 5 minus 12, then plus 9, right? So 5 minus 12 minus 7 plus 9 will give me what I'm looking for. So that's where the bracket is supposed to be. So it shows that we are correct with what you're doing. So the bracket will be at that point. So question number 3 says simplify 7x minus 8y minus x minus y. So I will just collect them directly. So I have this to this. I will now have this to this, right? So now let me put them together now. I have 7x minus x, then have minus 8y minus y. So 7x minus x will give me what? 6x minus 8y minus y will give me what? Minus 9y. So what is common here that can divide which factor or which factor will go into 6 and 9 without the remainder. So we have 3. 3 when 3 goes into 6, I have 2. Then 2 minus when 3 goes into 9, I have what? 3. So answer here is what? Right. 2x minus what? 3y. So question number 4 says the base of a cuboid measured 10 cm by 7 cm. The volume of the cuboid is 280. So calculate the height of the cuboid. So we know that the volume of the cuboid is given as what? Length times breadth times height. So we assume that this 10 and this 7 is given as this. So we're looking for height. So this one is also given as the volume. So we'll bring them down together. I have 280 is equals to 10 times 7 times the height. So I have 280 is equals to 70h. Divide both sides by 70. By 70. Cancel. H is equals to what? 0 cancel 0. 0. So 28 divided by 7 will give me what? 4. So I have 4. Question number 5. In the city, the probability that it will rain today is 0.15. Find the probability that it will not rain today in the city. It will not rain today in the city. So the probability that something will happen is 1. Something will not happen is 0. So since it rains, something actually happened. And of course, that means we just have to subtract it from 1 minus 0.15. And that'll give us 0.85. So the answer is what? 0.85. Question number 6. Say factorize completely, right? Factorize completely. So we have 4x squared y minus 5xy squared. So how do we factorize this? First of all, find what is common here. X and y is here. So x and y, you see x and y is here, x and y is also here. So since we have x and y here, x and y here, so it means it is the common thing that is there. So what we'll do, we'll bring it out. I have x and y being factored out, right? Because the word factorization means we should factor it out. So when x cancel one, when x go 4 has no business with that, we'll bring that 4 down. When x cancel one x is left. Y is cancelled, I have only this one left. Minus. When x cancel x, we'll bring down 5. Then 5 will have no business with it. When x cancel x, we'll have, when y going to this, I have what? When y cancel 1, I have y here. So my answer is just what? Xy in bracket what? 4x minus what? 5y. Question number 7 will say the scale of a map is 1:40,000, meaning that so on the question number 7 says the scale of a map is 1:40,000. On the map, the distance between two villages is 37 centimeters. So we should calculate the actual distance between the two villages, given your answer in kilometer, right? So first of all, this statement is in centimeter. So this implies that 1 centimeter is to 40,000, right, centimeter. So in this case now, we'll put it that means 1 centimeter is equal to what? 40,000 centimeter. So if on the map it is given as 37 centimeter, so how do we relate that? It means for 37 centimeter, we'll have 37 times 40,000, and that will give us what? 37 times 40,000. So we have a beautiful 1,480,000 centimeter. So the question is to calculate the actual distance between the two villages, giving your answer in kilometer. So we have to convert this to kilometer, right? So first of all, we already know that 1 kilometer, okay, let me continue from here. We already know that 1 kilometer is equals to 1,000 meter, because the word kilo means 1,000. And of course, we also know that 100 centimeter is equal to what? 1 meter. That also. So if we have these two statements, let's assume the meter cancel the meter. So let's know what kilometer implies in centimeter. So if we cross multiply here, it means we have 1 kilometer. We have 1 kilometer to be equal to what? 100 times, right? 100 centimeter times what? 1,000, which will give us what? 100,000, and that is what it is. 100,000, right? Centimeter. 1 kilometer is equal to 100 centimeter. So in that sense, so what is it now? Let's bring this one together. What is it when we bring this one down? 14. So we're going to take this one down here. 148,000 centimeter. So let's centimeter cancel centimeter here, right? So when we cross multiply, so we have 100,000, right? X equals to 148,000 kilometer. So let's divide both side by 100,000 by 100,000. So at this point, this will cancel this. My x becomes equal to, when 0 cancel 0, 0 cancel 0, 0 cancel 0, 0 cancel 0. 148 divided by 10 will give us 14.8. 14.8. Without using a calculator, work out this value. So without using a calculator, you must show your working. Give your answers as a fraction in the simplest form. So here, first of all, we pick out our LCM. So I have 3/7 minus 1/14. So my LCM is what? 14. When 7 going to 14, I have 2. 2 times 3 will give me what? 6. Minus when 14 going to 14, I have 1. 1 times 1, I have 1. So finally, my answer is turning out to become 6 minus 1 will give me 5/14. So question number 9 says, the diagram shows the right angle triangle. So calculate AB. So we're calculating this particular side, we're calculating AB, right? So if we're doing that, we will now be forced to bring in, since an angle is involved, and this is triangle, a right angle triangle. So we're going to invite Su and Ka and Tua, right? We'll check which of them satisfy the condition where this is your hypotenuse, because where the angle 90 is facing is usually your hypotenuse, right? Then where the angle itself is facing is usually your what? Opposite. And where then the other primary part can be seen as your adjacent, or you can use where the angle you're not considering is facing. So which of them? So that means we have here and here. We have adjacent. You understand? We have adjacent here. We have hypotenuse. So which of them gives us adjacent and hypotenuse? I think cos is the one that gives us that, because this is called cosine is adjacent over hypotenuse. So we will now do that here. So okay, we'll do that now by saying that cos 37 is equals to what? Adjacent, which is what we're looking for. So we can call it AB over what? Hypotenuse 8. So my AB is equals to 8 times what? Cos 37. And that will give us what? So we have cos 37 this, then times 8. We have 6.38. So my AB is equals to what? 6.389, which is approximately what? 6.39. So we can have 6.39. Question number 10. Find the gradient of a line joining the point -2, 7, and so you join the point, the gradient of a line joining the point. So we're looking at okay, let me sketch it here. A graph there, minus, of course, -2 will always fall at this point, -2, then 7 is up, right? So 7 will be, let's say 7 will always fall at the upside. So let's assume we are looking at it from this -2, here is -2, then 7, then and 3, x is 3. So let's assume x is 3 here, then let's say I have 1 here. So we're looking at from this point this way, so the line joins like this, and joins like that. So we're looking at it in that direction. So the question says we should find the gradient. So to find the gradient, which is m, so the gradient m is always given as what? Change in y over what? Change in s. And change in y is something as what? Y2 minus y1 all over what? X2 minus x1. So let's take this to be x1 and this to be what? Y1. Then we have x2, y2. So we bring them together now. We're having 1 for y, 1 minus 7, right? All over. We have for x2, we have 3 minus in bracket -2. So here we're having -6 over minus time minus will give us plus. So I have -6 over what? 3 plus 2 now will give me 5. So my answer is -6 over 5. So I have -6 over 5. Question number 11 says we should find the value of t in this equation, the simultaneous equation. So what do? We notice that we have a common term there already. We have this common term, so we don't need to give ourselves much stress. So we just leverage on that and just do our normal elimination method, right? So we put that. So which operation are we going to do here that will remove this common value here? Remove this common value here. Now it is very clear that we have -2w and +2w. So it will be easier for us to just add them. So we'll add. We will not do the usual subtraction since they are common. So we'll just add them. So we'll just add them by saying 5. We can, if we're starting from up, maintain up. If we're starting from down, maintain down. So I want to start from up. 5t plus 3t will give me what? 8t minus 2w plus 2w will give me 0. So that one is gone. 19 plus 5, right? 19 plus 5 will give me what? 24. So divide both sides by 8 by 8. Cancel. So my t is given as what? 3. I mean, so my t is 3. I will write my t as 3. So I'm looking for my w. So I can use any of the equation to find my w. So let me use equation. So let's assume this is equation 1. This is equation 2. So let me use equation 2 that is positive. So I'll be having 3 in bracket 3 because my t is 3. Then plus 2w equals to 5. So when 3 times 3, I have 9 plus 2w equals to 5. So collect like terms. So 9 will go up. 9 will cross over. I have 2w equals to what? 5 minus 9. So 2w is equals to what? Minus 4. Divide both side by 2. Cancel. My w is equals to what? Minus 2. So I have minus 2. So question number 12 says simplify this. So how do you simplify this? Well, first of all, we can simplify the number. So when 16 goes into 16, we'll have 1. When 16 goes into 32, we have 2 because 16 plus 16 is 32. Then we have G8 here, we have G16. So we'll remove the 8, G of this, the G8 inside G16, 8 to be left. So our answer here becomes 2G8. So I have 2G8. Because the B part of it say we should simplify this. So we're still simplifying. So here I have 625K is power 8 in this. So what I'm going to do right now, I'm going to write this thing to be 4 cube roots, because this is the laws of indices. If you have studied that, 625K8, then I'll bracket what 3. So I've written this because according to laws of indices, if I have A, let's power of 4, it's something as what 4A. I hope you know that. If it is 3 that is here, it is 3 here. If it is 2, if it is 2, then there's nothing there to be square like that. So that is what we're trying to use in this case. So I have done this. So the next thing to do is there any number I can multiply into 4 places to get 625? I think it's 5. Because 5 times 5 is 5. 5 times 5, 125. 125 times 5 will give me 625. So it's 5. So I have is to be equal to 4 cube root of what? 5. Then for k raised power 8, it means I can have it as k square in bracket now s power 4. So because 4 times 2 times 4 is 8, then I have all bracket what 3. So this 4 can now humbly cancel this one for me. What I have here is 5k square all in s power what 3. So I can break it down. When 5 is cubed, I have 1, 2, 5. When k is cubed, I have k is power what 6. So my answer is what 1, 2, 5 k to the power of what 6. So question number 13 says shade the region that is given as this particular value. So we're going to be shading that region now. What I'm going to do right now is, if I am you, I'll just break it down, right? I'm shading that region, so I'll break them down. So let me draw for this, for A first, right? I can draw for, so if here is A, I'm to shade A, I'll shade my A all through completely. Let me draw for B. So my B is like this. So if I'm to shade B prime is outside, so outside B like this. So when I put them together now, it means all the A's are shaded, right? All the A's are shaded, right? If you don't understand this, I'll also show another method. All the A's are shaded because then B prime outside, so that means outside is also shaded. So I have all the A's outside shaded, removing, so are shaded. So you can use your pencil to do the correct shading, leaving B inside. That is what they want you to do then, leaving B inside. Now, if you don't understand using this one, you can if you don't understand using this system as a whole, if you don't understand using this system, you can assign numbers to it. You can, if you don't understand using this system to obtain a result. So if you don't understand using this system to know the actual where you're going to shade, you can assign numbers to it. Let me show you how to do that. So what you will do here is you look at what you have here and name them 1, 2, 3. Are you following? Then since we have a prime, I can call this one 4. So your A is what? 1 and 2. Then your B is what? 3, is 2 and 3. Then also good. That's your B. So but your B prime is needed because of this B prime here. So your B prime is needed, which is what? Removing 2 and 3 from let's take our universal set as 1, 2, 3, 4. So removing 2 and 3 from the equation, so I'll be having 1 and 4, right? So 1 and 4 becomes my value. So now I'm finding the union of A union B prime. That will give me 1, 2, because this is what we're talking about here, this and this. So 1, 2, and 4. So you shade all the area that has to do with 1, 2, and 4. So I will shade 4 is outside, so it's part of the deal there. I will shade him like that. So I have 2 also involved to be shaded. So this one, I think this one is easier understood. So you can do that and you're free with your answer. The B part of it say we should shade the region. So we say, use the set notation to describe the shaded region. So this one may be a little bit complex, but it's very easy. So what you do here, you do the same thing that I told you. You can name them 1, 2, 3, 4, 5, 6, 7, just like that. They're doing this now because you start by knowing your angles. So let me start by saying my P. What's my P? My P is everything. 1, 2, 4, and 5, right? Then what is my Q? My Q is what? 2, 3, 4, and 6. Then what is my R? My R is what? 5, 4, 6, and 7. So now Now we'll start looking at these values now. Okay, I have gotten everything I'm looking for here. So I want to know this particular one, not shaded. So for these two of them not to be shaded, I can put them as a union. So let me say that means if I have my P union Q, will give me what? It will give me these two together. That means I have 1, 2, 3, 4, 5, because 1, 2, 3, 4, 5, 6. So I'll have this like this as P union this, right? Now I am going to look at this from that angle and say, okay, what I'll do here right now is uh let's, because it's not shaded, it's excluded. So we have gotten that for that particular part, our union of this. Now for for this this is a union of these two. Since it is not shaded, let me take the complement of that particular part. P union Q complement will give me are you following now? It will give me P union this complement will give me, because if I take my universal set as 1, 2, 3, 4, 5, 6, 7. So if I take the complement of this, I mean I'm excluding this, so I'll have 7 left. Now 7 left. Remember my R has 7. That also. So the best thing now to do is to intercept these two together. So I have my R intercept P union Q complement, which is what? 7. So 7 is now the shaded region. So it's now clear that the answer is what? R intersection P union Q. So that will help you to solve your Q prime. That will help you to, so using this method of numbering them will really help you to know your answer for. Is that clear? Okay, question number 14 says P, Q, R, and T are points on the circle. AB is a tangent to the circle at T, and AB and the angle ATP is 50, angle PTR is 48, angle PQ and is equal to QR. We should find PRT. When you say R at the middle, it means it is the angle you are looking for. This. Now you should be able by now would have mastered your circle theories, right? So there's a theory we call alternate segment theory, right? Alternate segment theory. Okay, let me write it in full. Alternate segment, right? Theory, right? So which says that if I have a circle like this and have a tangent line that crosses that line at me, if a triangle is formed on that angle touching the tangent line, now the angle here is usually equal to the angle here. It's called alternate, and the angle here is usually equal to the angle here. So if here is x, here is what? X. If here is y, here is what? Y. That is what the alternate segment theory says. So if you apply this theory here, you can clearly say that here, if here is 50, if you apply that theory here, you can clearly say if here is 50, that means here is also what? 50. If you're not satisfied with that, I can prove it to you here. Okay, let's try and see if we can prove this to be true. So let me assume this is the point, center of the circle. So let me draw a tangent. For it to be a tangent, it means there's a straight line that crosses it. So let's assume this is a straight line that walks it through. So in that case, so let me assume this is a straight line. So that's what basically tangent line, like a 90-degree line that crosses it. So let me connect this point and form a radius from this straight line. So let's try using this to prove it. So if you're not satisfied with the condition, now one of the circles theory also say that whatever angle you have here 48 is the double of it is the angle you're going to have here. Am I correct? Good. So double of the angle you're going to have here. So but let's leave that one for now. Now for this to be 90, for this to be tangent, there's a 90-degree there. So if from here to here is 50, it means we have 40 left here. Am I correct? So here the remaining part is 40. So if the remaining part is 40, remember we say that this particular line and this particular line is 48. That means here is what? 8. Then also that place is 8. So remember this line comes from the center, which is the radius. So it means, and this one comes out, means this line is equal to what? This line. So if here is 8, here is automatically what? 8. Then also good. Now we now bring in the other rule, which says if here is 48, remember the theory that says this particular y here, this particular one here, the double of it. So the double of whatever you have in 48 here, you have here, double of whatever you have here is what y is. So if here is 48, 48 times 2 will give us 48 times 2 will give us what? 90, 96 bar. So we have 96 there. So now if here is 96, for this, remember the sum of the triangle, sum of the angle on the triangle is 180. That means we have 48 here. We have these two must be 48. What would that need to do? Because they are equal, right? Because they are equal. Because they are equal. That means the remaining part is 48. 48 divided by 2 will give us what? 24. Here is what? 24. So when you sum them together like this, 24 plus 8, you have what? 50. So 50. So if you don't remember the what do you call it? This alternate segment theory, you can always solve it, and of course the answer is always the same. Question number, the B part of it says, find angle PQR. Angle PQR is this point. Let me zoom in a little bit so that we can see it together. So angle PQR, this is my P, this is my P, right? So I have my PQR. So for P to be at the center, meaning that we're considering the angle inside, right? So let's find the angle inside. Now, there's a theory also in circle. That's why I say you go and master your circle theory. That says the angle at this particular point, when you have a triangle that forms, like this inside a quadrilateral that forms. So not the triangle that forms inside, right? The opposite angles are equal to 180. So if here is x and here is y, so y plus x is equal to what? 180, right? Equals to 180. So in that case, since I have this like this inside, so I will consider them. It means whatever I have here is equal to plus whatever I have here is 180. So since I have 48 here, 48 plus 96 here will give me 180. So I'll write 96. Remember, these lines are equal. So if 96, the sum of the angle of the triangle is 180. So it means here I'll have 24. I'll have what? 24. So with that, the question did not say you should solve, show yours working. But with that, you can now say, okay, or you can quickly show your angle. You can show your value by summing them. So you have 24 because the angle there is 24. And the same question. So our answer here is what? 24. Question number 15 says we have this, right? Say the time taken for each 200 students to complete a calculation is measured. The cumulative frequency diagram shows the result. So shows the result. The question now wants us to use the diagram to find an estimate for interquarter range. So you don't forget your interquarter range is what? Difference between the Q3 minus what? Q1. So the third quarter and the fourth quarter. The fourth quarter means 1/4. So that means I have 3/4, right? Then 3/4 of the students. So of means times. So times 200 minus 1/4. The first quarter, 1/4 of the students. Okay, let me use the same times of the total students is 2000. So when you bring this one down, you have 3 times 200, 600. 600 I have 150, 150, right? Then minus 15th. So let's break them down. So for 15th, what's the time taking? You calculate the time taking. Please don't try to subtract before looking for the time. You may not be able to achieve your answers directly. So find them separately, then you cannot subtract them. So for 50, we look at our graph and find where the 50 lines, touches this stuff. So for us to get the 50, we will check what is the range, what is the difference in this. So cumulative frequency, you have 0, 20, 40, 60. So we notice that it is 2020. Now in that 2020, we can break it down. Like I told you, the difference is 20. So how to calculate your lines? Don't need to be stressing yourself. Just go straight. Since you have the difference to be 20, you write it down 20. Divided by, of course, it's always 5, right? Because our each unit have about 5 lines. So 1, 2, 3, 4, 5. So each unit have about 5 lines to the next number. So we divide it to have what? 4. It means each of these ones are 4, 4. So here I have 24, 20. Then you're adding 4 to the to get also 24. Then 28. Then you have what? The next one is what? 24, 28. You have 32. You have 36. Then you have 40. So now that is what it means, right? So we come to the area where we have the 40 to 60. So it means we can say, okay, here is 40, 140, 144, 148. Then here is 152. So we have exceeded. It means it's at the half side of it here. So we take note of the half side of it here. So now we're going to draw a line to touch the line at that half side. So we do that, and we have our point there. So we take the readings for this one too. So here we have 20. So what's the difference from here is 10, right? That means each of these units is 1. So 21, 22, 23, 24, 25, 26, 27. So my for 50 I have 27. Now let me look for 150. I have 27. Let me look for 50. So for 50 will give me what? 50 is between 40 to 60. So it should be the half too. So it should be at the half side too. So we check 44, 48. So it's at this particular point here also. So we trace it to this curve. So it at this particular point. So if I join my line, I will have it like this. So, and that is going to be at this point for me. Good. So if here is 10, 11, 12, 13, 14, 15, 16. So I have 16 here, right? Just like I have what here? 27 here. So when you bring them together, you're able to know. So 17 minus what? 16. That will give us what? I think 11. So we've got an answer as 11. So the B part of the question says the number of students that takes more than 40 seconds to complete the calculation. So it is clear that we're looking for those that took part, that this particular part, right? So 40 seconds is in this place. So let's trace the line to the curve. Then from there we can now know where the line to the curve. So when we trace it to the curve, we'll have this. So it's at the middle point there. So it means what's the figure there? Let's calculate. Remember, each line there represents 4. So if you add 4 to 180, you have 184, 188, 192. So it's between, here's what we want, 196, but it's down here. That means we're dividing this 4 into 2. It becomes 194. I have 194. So at that point, we have 194 there, right? We have 194 there. Meaning that those that took more than that will be what? The difference between 194. So I have, it will be 200, which is the total number of students, minus 194 will give us what? 6. So I have 6 as my answer here. Now, question number 16 says that we should find what? We should make H the solid of the formula. So it's actually very simple. What you do is to move these values outside. You can leave this one alone. This is the subject we're looking for. So it will become, to rearrange it. So A, right? A, because when pi r square equals to minus pi r square is equal to what? Pi dh, right? So we divide both sides by the pi d by the pi what? Pi d, right? So we have pi d. So pi will cancel pi, and h becomes a minus pi r square all over what? Pi d. So I have a minus pi r square over what? Pi d. Okay, question number 17 says work out giving each answer in standard form. So we're trying to do this reason. So here I have 2.1 times 10 as well. So we're going to apply your normal indices, right? So the truth about it is that if you are not careful, you may be deceived by thinking that you're going to factor out anything out. Or no, rearrange it. I think rearrangement is going to help you. So you have 2.1 times 8 times 10 to the power of what? 101 times 10 to the power of what? 101. Because multiplication is usually commutative, right? So here we have 2.1 times 8 to give us what? I have 16.8. Then times for this one now I have, we take since they are the same index, we sum the index, so the same base, we sum the index. So 101 plus 101 will give us what? 202. But we can't even answer like this because 16 is not in standard form. 16.8. So standard form means decimal point has to come after the first number. So that will give us what? 1.68 times 10 to the power of what? 202. So sorry. So that will give us, so when we write 16.8 in standard form, we'll have 1.68 times 10 to the power of what? 1, right? Then because decimal point will count once forward, so it becomes 1 here. So times 10 to the power of what? 202. So when you break them down like this, for this one, you have our answer will become 1.68 times 10 to the power of what? 1 plus 202 give us what? 203. So answer is 1.68 68 times 10 to the power of what? 203. The next one says we should solve this particular one. So at this point, what I want to do here is simple. Since I have addition here, I can factor out, right? Good. I can factor out the common thing there. So since I have addition there, I can be tempted to say, okay, let me factor out the common thing. But something is not common for me here. So which I can just come here and say, okay, I have this. So 2.1 is here, 2.1 is here. So under addition, you can factor out. So I have 2.1 being factored out here. I have 10 to the power of what? 101, right? Good. 101 plus what? 10 to the power of what? 100. So I cannot, don't be tempted to say you want to add the index. Since the operator here is plus, is addition. You only add index when the operator is multiplication, and you subtract index when the operator in between them, the binary operator there is subtraction, is division, sorry. So the for here we have plus. So what I'm going to do here is to further split this one. So since I have 101, I can separate them. So I can say I have 2.1 in bracket what? 10 to the power of what? 100 dot 10, right? I'm using dot product here, or let's also maintain times. Now, this power 1. So because with these two, I can have this with this 101 back, Abby. So then plus what? Plus 10 to the power of what? 100. So at this point, I have now gotten the common thing here, which is what? 10 to the power 100. So I have 2.1, right? In brackets. What is common there is 10 to the power of what? 100 in brackets. I have 10 to the power 1 plus, for here I have 1, right? So here I have 2.1 in brackets, 100, right? Of 100 equal to here I have 10 plus 1 will give us what? 11. So multiply 2.1. So if I have 2.1 times 11 will give me 23. So I want to split them. So I have 11. I want to multiply this by this so I can reduce my factor, my values. So I have 23.1 times 10 to the power of what? 100. Well, 23.1 is not that one. So points will have to move to the first number, so which is by 10. So I have 2.31 times 10 to the power of 1. Then times 10 to the power of 100. So when we bring that together now, we have 2.31 times 10 to the power of what? 101. So my answer here is what? 2.31 times 10 to the power of what? 101. So question number 18 says the diagram shows two sides, VA and VB, of a regular polygon. AVX is a straight line. So we have to find BXV, meaning that angle at Y, angle at V is Y, and angle at V from the other side of AVB is 11 points. So here is what? Y, and here is what? 11.5Y. So of course, one thing that we know very well is that the sum of an angle on a straight line is 180, right? It's usually 180, meaning that 11.5y plus y is equal to what? 180. So here I have 12.5y is equal to what? 180. So if I go side by 12.5 by 12.5, this will cancel this. My y is equal to 180 divided by 12.5. So when you do that, you have 14 point, right? 0.4. So my y is 14.4. Remember, it's a polygon, and we're looking for number of side. So if you're looking for, and of course, we're going to use number of side. We're going to use the exterior. So the exterior angle of a polygon, right, is equal to what? 360 over what? N. Because that N is so because we're looking for the angle at the exterior angle. It's one number of side, which is N. So at this point, the number of side will come. That will give us 360 over 14.4. So 360, right, divided by 14.4 will give us 25. So my answer here is what? 25. So question number 19 says describe fully the single transformation that map triangle T on triangle W. So we're looking at what map this triangle T to this triangle, right? So now clearly you can see that initially the edge here is like this, now it now turns like this. So it is not, we have four types of transformation. We have the translational transformation, we have the reflectional transformation, we have the rotational transformation, and we have enlargement, right? So they are the four types of translation. So translation is when something moves from one place to the other in a linear fashion. Then we have the second one, which is rotation. Rotation is when something moves, when something used to be like this, then it rotated to something again like this, right? Then we also have the reflection. It's like a mirror, right? Like a mirror. So if I have my right hand, if I have my right hand, here in this area, my right hand will be facing left. So if it's facing right here, it will be facing left from the mirror side. Then we have enlargement. Enlargement is when something grows bigger, right? Something grows bigger. So these are the four. Now let's go back to the question. The question wants us to describe what kind of transformation. Is it reflect? Is it reflective? Is it rotational? Is it or is it enlargement? So clearly you can see that it was like this. Then you now rotate, touch like this. So it means it is rotational, right? Now, at what is a single transformation. So at what part of the graph did it rotate? If you notice, if it rotates once, a single transformation, so it means it rotates at 90 degree. So 90 degree. How? Clockwise, right? Because if your clock is like this, so that seconds line, you see the way our minute line, they go like this, they turn like this. That means it's clockwise. But if it goes otherwise, it becomes anti-clockwise. So we take note of that equally. So the next one I want to do is because when you're talking about rotation, you have to mention two other things, which is the angle of rotation and also the center of rotation. So the angle of rotation clockwise. Now center of rotation, how do you get that one? That one is actually very easy. Now it's either you use a tracing paper or you use your protractor, right, and ruler. So or possibly you also use your pair of compass, right? So let's say you're using your pair of compass. What you will do is at this point, at this point, you have to pin and compass. On this point again, you compass. You get the middle point of this line to this point. Then you cross the line. Then you do the same thing for this one also. You put the protract. Then you put the protract. You join the line again. Then here the same thing. You put the contract, right? And so this is what you can do, right? And then way you want to do this is if you don't have protractor like me, I'm using screen to solve. So what I'll do is that I'll just use my ruler. I'll just connect my ruler. I'll connect this point of my ruler. So we connect the points, all of them, if possible. Then find the middle of this ruler, the mean of this of the ruler. Find the mean of the ruler, and then when you find the mean of the ruler, that will make it perpendicular. Hmm? By set this ruler by 2, I'll make it perpendicular. Then make sure perpendicular. Make sure that if you're using a protractor, make sure that your 90 is resting on the middle. Then you can cut, right? When you do that, you can now join it with you join it with this. Don't join it like that. So that will give you the point of rotation, right? So let me show you how it works. Let me show you. Now let's say, okay, I want to show you how this thing works, right? Um, so what I'm going to do is that I'm going to draw a line joining the vertex, right? I'm going to draw a line on the vertex. If I draw a line, my line will be if I pick this point and pick this point, I form my line, right? I form my line. Now I'm going to find which line will make it perpendicular. So I'm going to bisect the line, right? I'll bisect the line, then I'll do the same thing I did here. It will bisect on its own like this for me. Now I'm going to do for this one too. I'll draw a line too for this one. For this one, then I'll now this one is of this edge here, right? So for this line, I will do so I'll bisect it equally. You know, I was passing about so you can even stop at that too. But if you want to continue, you can continue to know. So it's stopping at the origin here. So let me continue again. Let me do the last one. The thing is that if you get it accurately, your line will not disappoint you by making it perpendicular. Now you notice that all of them crosses at when y is 0, x is -2. So that is how the point works here. So all of them converges. So the point of rotation is uh, is uh, is -2, 0 and -2, right? The point of rotation here is at what 0 -2. Now the next question wants us to find draw the enlargement of a triangle T with the scalar factor -2 and center of enlargement -1 and -2. Scalar factor means it has to be on our left hand side. Then the enlargement center is -1 and 1. So we want to look for that one first, which is at this point. At this point. So now to know the point of enlargement, which is -2, that means we are multiplying whatever we get in T by 2. That will give us how enlarged it is. So let me start from the vertex of each of the angles in T. So let's start with this one. So I'm going to count downward to get to this point of center of enlargement here. So if I count 1 like this, I'll come here and I count 2. So this from here to here gave me 1. So I will now count 2 for this one. I'm multiplying it by 2. Then this one give 1, 2. I'll now multiply the left hand by 4. 1, 2, 3, 4. So my answer here is this side. So I'm going to clean all these ones. So now the next one is to know from this particular angle here. So I have 1, 2, 3, 4. So at this point I'll count 4. I'll count 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is my point. Then I'll now count by left. 1, 2, which I count 4. Okay. So I have 1, 2, 3, 4. Mark. They will count from here also. 1, 2, 3, 4. So we count. Now we should still add the 4 here. So normally this is not part of the day. So we still have the 4 here. Then we have 1, 2, 3, 4. So we have 8 there, which is at this point of 8. Then we now count 1, 2, 3, which is 6. 1, 2, 3, 4, 5, 6. So you see that is the point of this one we're looking at. So we can join the line. Join the lines. So join the lines. So this is my T1. That's what the coach wants us to do. We are done with that. See you in my next video. Question number 21 says, write the recurring decimal as a fraction in its simplest form. You must show all your working. So first of all, let's take x to be equal to the value of 0.41 dot. This 41 dot here means it is one that is recurring. So this is equivalent to writing x to be equal to what? 0.411111 up to infinity, unknown to 0. So let's multiply 10 to both sides since we have one unit here. So let's multiply 10. So I have 10x is equals to what? 4.1111 like that continuously. Because when I multiply 0.4, 4 will be left. So let's also further reduce it to multiply by 100 again. That means we have 41.1111 like that. So we can call this equation 1, equation 2. So when you subtract equation 2 from equation 1, here you have 90x, which is equal to this one now. 41 minus 4 will give us 41, right? Minus 4 will give me 37, whereby all these ones will go. So divide both sides by 90, so your x becomes 37 over what? 90. 37 over 90. So 37 divided by 90 will give us is the fraction. So that's what we have as our recurring value, right? 37. So question number 22 says solve the equation. So first of all, we make it to be non-homogeneous. We have tan x plus root 3 equal to 0. For 0 degree is less than or equal to x less than or equal to 360. So we have our tan. We can make it. We can say that means our root 3 can cross over the equal sign. So I have tan x is equal to minus root 3. Right, so one tan cross over the equal sign, because we want to make x a subject. We have x is equal to what?
minus tan inverse of what? Root 3. So that will give us x equals to minus tan inverse of root 3 will give us 60. So we have 60 negative. So the next thing we want to find out here is where we draw our quadrant to know exactly where tan is negative in this quadrant. So from here we know all of them are all positive here. Here only cos is positive here, only tan is positive here, and only sine is positive here. So to remember this thing on time, just write at, right? Out of the apostle, at. So when you write at, you take out clockwise. So out clockwise will give you the picture so that you don't always forget. So now at this point we have 180 minus degree, because from this point to this point is either 180 or less than 180. So here you have 180, plus degree. So when you move down to this point, it's either 270 or less than 270. So then from this point again, you have 360 minus degree. So it's either equal to 360 or less than 360. So here we have, at this point, we can now say, okay, where is my tan negative? My tan is negative at this, right? My tan is negative at this or this. So if that's the case, right, my tan is negative there. So if we remove, that means here, if I remove 180 minus 60 will give me 120. So 120. And now here, if I remove 60 from 360, I have 300. I have 300. So that is the areas where your tan is negative. Alright? That's the area where your tan is negative. Question number 23 says we should simplify this, right? We're simplifying this. So what do? We collect the LCM. The LCM is two of them, right? Y plus 1, then y. So when y cancel this y here, right? When this y cancel this y here, only y will be left. Y times 2 will give me 2y minus when this y cancel this y here, then y plus 1 will be left. Y times 3 will give me 3 in bracket what? Y plus 1. So when you open a bracket here now, we'll have 2y minus 3y minus 1 minus 3, right? Because 3 times 1 is 3, all over what? Y plus 1, then y. So this will give me 2y, right, minus 3y will give me what? It will give me minus y, then minus 3, all over what? Y plus 1, then y. So I can factor out my y, my minus out. I have minus in bracket what? Y plus 3 all over what? Y plus 1, then y. So that is my answer for this equation. I can have 1 minus y plus 3 all over what? Y plus 1. You say, okay, single fraction. Okay, so okay, the question wanted us to put it in single fraction. So we can remove this. So at this point, I'll have minus in bracket y plus 3 all over y times y will give us what? Y square, then plus y. So I have minus 3, sorry, my answer is now minus in bracket what? Y plus 3 all over what? Y square plus what? Y. 24. So the diagram shows a rectangular prisms with cross section triangle BCV. Then angle BCV is equal to 90 degree, BC is equal to 5 cm, CV is equal to 4 cm, and AB is equal to 15 cm. Calculate the angle between AV and the base ABCD. So at this point, we have to calculate AV. So this particular place is the base, right? So we are between AV and the base ABCD. ABCD. So what we want to calculate now is AV. So the first thing to do is to let's get AC first. Let's get AC first. So let me try and put it in order. Let's get AC first. Now with this, we need to calculate the angle between AV and the base ABCD. So since we have gotten this, we can bring it out. We can bring it out and say, okay, we have a right angle. We have something like this. So we're calculating here is what, 5 and 15. So let's find, because that is my AC that I'm looking for. So I'll use Pythagoras theorem to find what here is. So my x square is equal to what? 15 square plus 5 square. So 15 square is equal to 225 plus 25. I have 250, right? For what? For x square. So x is equal to what? Root what? 250. So my x is equal to root 250. Root 250 is equal to, so I have 5 root 10. So now we are looking for calculating the angle. So it is an angle. So let's bring it out. What we have that is left now. Here I have 4. Here I have 5 root 10. So we are looking for the angle, right? So which of the two are connect? Which of the two are connect adjacent and opposite? So we have tan. So it will be tan theta is equals to opposite, which is 4 over what? 5 root 10. So 4 divided by 5 root 10, that will give us 0.2529 for tan theta. So if we break that in half, theta is equals to tan inverse of 0.2529. So second function, tan answer, right? That will give us, we have 14.196. I can just say 14.2, right? Which is approximately what? 14.2. Question 25 says, simplify this. So I have pt minus p minus t plus 1. So how do you simplify this? I have my p here, I have p here, so I can factor out the something else. I have p being factored out here, I have t minus 1, then minus, then if I factor out minus, I have t minus 1. So here I have 1 minus t, so which is something as what? 1 minus t. If we break them down algebraically, we have 1 plus t. So here minus t is common, so I have t minus 1, I have p minus 1 all over 1 minus t, I have 1 plus t, right? Now my problem here, there's nothing common here. The only way to make this in common is to reverse this thing, so multiply by minus here. So when I do that, I'll have, if I multiply 9, if I write it, I can write this as what? I can write the up one here as minus in bracket what? 1 minus t. I have p minus t minus 1 all over what? 1 minus t. I have 1 plus t. So this will cancel this for me. I have minus p minus 1 all over what? 1 plus t, and that's my answer. So I have minus p minus 1 all over what? 1 plus t. That's my answer. Or we can write it, when you can allow your minus to open, you can write it as minus p plus 1 all over what? 1 plus t. So which answer was 1 minus p over what? 1 plus what? T. So if we okay, since we have to simplify, so that becomes our answer. Because to simplify it, right? So we have 1 minus p all over what? 1 plus, right, t. So we're simplifying it. That's simplification. Question number 26 says we should find this particular, to find the position vector of s in terms of p and q when OP is given as p, OQ is given as r, and of course PR is to the ratio of PQ is the ratio of PR, which is 1 and 2. So here what I have here now is, what I have here is what? Here is 1, right? Here is 1, and here is what? 2. So when we sum the ratio, we have 3. So that means here is, if PQ, so that means here is PQ, here will be 1 over 3 PQ, right? 1 over 3 PQ, and here is what? 2 over 3, right, PQ. So PQ. Now let's assume, which direction are we taking? We have two directions here, so take note of the direction. This is going this way, this is going this way. So but if we assume, if we take this direction like this backward, so let's say we take this direction this way, we must maintain that. That's our direction. So we can't be going up and down, except we have to negate a particular part. So if we go that way, say we're picking this way now, so it means that our value for that particular direction is maintained. So at this point, if I pick OQ as my vector to deal with first, if I say I pick OQ direction, so it will be O. It's supposed to be O because I'm working on P. I'm working on in triangle PQO, right? PQO now, or OPQ. So OQ will be OP, right? Plus what? It will be supposed to be OP. That means so it's supposed to be, so if I am going this way, it's supposed to be like this, but OQ plus what? PQ. But the problem here is that okay, let me start from the top side. So let's say I'm picking PO, for example, direction PO. Now, but my PO is in negative form, so let me just address it that way. It's equals to P, right? PQ, right, plus Q what? O, right? So that means I'm changing my direction to this point because I'm going that way. I'm going like this. But the problem I have is that this one refuses to go this way. It's either going this way. That means I'm going to negate it. So I have PQ is equals to what? So PO, right, is equal to what? Then since my PQ goes well, no problem. That means the values you have here is for that. Same as is for that. So I have PQ, right? Then minus, because this one negates the movement, so it's minus what? It will become minus QO, QO direction. So now my OP is P equals to what? PQ, right, minus Q. So here I have my PQ to be equal to what? When Q comes to y, I have P plus Q. So that means this value becomes P plus Q. So now I'm getting what I'm looking for. Remember, if I'm going in direction, okay, let me still pick the O. Don't worry, everything is still OP is equals to, let me still arrange it normally how it's supposed to be the vector. It's going to be O, right? OR, right? Because OP, what if I say RO? So OR good plus what? P, right? OR plus PR. POR plus PR. Now for my OP is P, no problem. That amount, my OR is what I'm looking for. OR is what I'm looking for. Alright, no problem. Then plus what's my PR? My PR, remember, my PR is going to, my PR will become 1 over 3 in bracket what? P plus Q. Then also, so if I bring them together, so let me move it to the other side. I have P minus 1 over 3 in bracket P plus Q is equals to O R direction, right? So open the bracket, I have P minus, right? Okay, let me just take LCM here direct. LCM here is what? 3. So I have 3P, right, minus P plus Q. That will give me 2P plus Q all over 3. So this is what my OR is. So my OR is that now. So now, since I'm looking for OS, it means I'm multiplying by 2. So to me, my OS will become equals to 2 in bracket what? 2p plus q all over 3. So which will give me 4p plus 2q all over what? 3. I think that should be the answer. That should be the answer. So this is actually very simple. It's just simple calculation. So we can split them. I have 4 over, it's actually very simple, then p plus 2 over 3q. So that will give us the answer. So thank you for watching. See you in my next video. So we'll be starting 3.3, 31, 32, 33, 41, 42, 43 before we now move into the. So thank you for watching. See you in my next video.